and welcome back to another video of CHE 101. So for today, we will be discussing phase diagrams under Physical Principles 2. So for the outline of today's discussion, we will have phase diagram, the definition, the parts, and the multiple component systems. Then we will proceed to the Gibbs Phase Rule, and then we will have some exercises to test our knowledge. So first, phase diagram. Basically, ang phase diagram is normal graph lang siya of pressure and temperature. Pero dito, na-visualize na natin yung physical states ng substances natin through the graph. So makikita nga natin dito is meron na siyang points at the graph na malalaman natin if solid, liquid, or vapor yung ating substance. And we have pressure versus temperature graph. So yan, parts ng ating phase diagram is first we have the phase boundaries. Ito yung lines or curves na nagsaseparate ng two phases. Ayun nga, since boundary siya yung nagsaseparate ng phases natin. So ito siya, itong mga lines na to. So phase boundary rin to, and ito yung phases natin. So since separate nga ng two phases, this means na ibang phase ito at ibang phase ulit ito at ibang phase ulit ito. The next, ang phase boundary din natin is yun yung location ng phase transition natin. So since nga nag-iiba yung phase in between nito, syempre para mag-iba yung phase, magta-transition muna siya. And dito yung locations ng mga transition na yun. Yun, para kang tumatawid talaga ng gate or border. So meron tayong solid liquid boundary, ito siya. Liquid vapor boundary, and then solid vapor boundary. Yung sa solid liquid, site nga siya ng freezing and melting since boundary nga siya ng between solid and liquid. Then yung liquid vapor, between siya ng liquid and vapor, kaya ang nangyayari doon ay condensation and evaporation. Then meron din tayong solid vapor, which is yung forced deposition or sublimation naman. So next na property natin is yung triple point from the word itself or the term itself, triple point. So siya yung intersection ng ating mga phase boundaries. Kaya triple point kasi tatlo nga. Then, dun, nagko-coexist yung three phases natin since nasa intersection siya. Then, meron na tayong critical point. Ito naman siya. So, liquid and vapor to. So, ditong part, hindi na natin yung liquid and vapor phases natin, indistinguishable na siya. And, ayun nga, for water, meron tayong critical temperature, which is yung temperature at the critical point, na 374 degrees Celsius, and critical pressure na 217.75 atmospheric pressure. Then, terms lang na need natin matandaan is pag sinabing normal condition, 1 atmospheric pressure siya. Then, for standard, that's 1 bar. Ayan. So, yun yung for single component natin. What if multiple component system naman? First, we have binary systems. Sa binary system, ang pinaplot natin is isang parameter versus yung fraction ng component. So, etong parameter na to, either pwede yung temperature, parang dito sa graph, or pwede rin naman pressure. Then, meron ka dito sa x-axis mo yung fraction niya, percent by mass, percent by mole, pwede. So, makikita natin dito yung mga phase boundary in which is yung liquid composition dito and yung vapor composition dito. Then dito, in between nila, is nag-exist yung two phases natin. So, merong liquid and vapor dito. So, for ternary systems naman, yung possible phases and equilibrium for a combination of three components at constant temperature and pressure ang makikita natin. So, constant temperature and pressure ito. So, parang ito kasi, imaginein mo na para kang may pyramid, di ba? 3D. Tapos, yung height nun is parang pwedeng temperature and pressure. Tapos, pag in-slice mo kasi yan, ito yung phase na yun. Tapos, pag nakaano nga, is constant na yung temperature and pressure mo dun sa slice na yun. And sana na-visualize nyo yan. Then, moving on, doon na tayo sa Gibbs Phase Rule natin, which yung nagpro-provide ng number ng variables na pwede natin baguhin independently without changing the phase equilibrium. So, ito yung equation niya. F is equal to C minus P plus 2, wherein yung F natin yung degrees of freedom natin. C yung number ng components. P yung number ng phases. And for a one-component system, so C is equal to 1, substitute natin yun, 1 plus 2, so 3 minus P, ang degrees of freedom mo. So example natin, helium gas. Ang helium gas, isa siyang one component system lang siya at may one phase lang din siya. So solving yung degree of freedom natin, 3 minus 1 is 2. So, meaning nun, need natin na may two thermodynamic variables para ma-determine natin yung state ng ating helium gas. So, kunwari meron tayong volume na, tapos binigay na rin yung temperature natin. Ayun, may two thermodynamic states na tayo naala. Thermodynamic quantities na alam. So, hindi na natin need malaman yung pressure natin para malaman yung state ng helium gas. Ayan, moving on, meron na tayo, proceed na tayo sa ating exercises. So first, how many phases exist at each of the points? So take note lang, need natin maalala, so P versus T to. So single component tong system na to. Unlike sa binary system natin, which is yung parameter dapat versus yung mole fraction. Yan yung distinguishable between those. So, yan. Moving, meron tayo kay A. Since nandito lang siya, wala naman siya sa any boundary, one phase lang siya. Ayan. Then kay B, since nag-intersect tong mga to, 1, 2, 3, meron kang 3 phases dyan. Kay C, wala rin naman siya sa mga boundary natin. So, one phase lang din yan. Kay D, nasa in-between siya ng dalawa. So, 2 phases. And kay E, nasa in-between din ng dalawa. So, 2 phases din yan. Ayan. So next, what is the maximum number of phases that can be in mutual equilibrium in a 4-component system? So, need muna natin si Gibbs Phase Rule natin na equation, which is ito, F equals C minus P plus 2. So, 4 components. So, C is equal to 4. So, manipulating that, we have F is equal to 4 minus P plus 2. Tapos, pag inequate natin, pag simplify natin yan, F is equal to 6 minus P. Then, alam naman natin na ang phase and degree of freedom, hindi dapat siya magne-negative. Kasi wala naman tayong negative number of phases at negative na degree of freedom. So, dapat walang magne-negative dito. So, at most, 6 lang yung pwede mo kay phases para hindi mag-negative si degree of freedom mo. So, yun. Ang sagot mo ay at most 6 phases. Yun sa 4-component system mo. Next, at which of the following pressures does solid carbon dioxide sublime with an increase in temperature? And i-analyze natin yung problem, sublime daw, meaning solid to vapor. Saan ba dito ang solid, liquid, and vapor? Solid, liquid, vapor. So, dapat ang transition mo from solid to vapor. Pag nandito ka na, di ba, pag mag-increase ka ng temperature, dadaan ka dito, solid to liquid to vapor yan. So, hindi pwede mangyari ang sublimation. So, sa graph na to, kailan mangyayari yun? Pag nandito ka, kasi ito ang solid, ito ang vapor. So, that below dito. Below around, siguro sabihin natin 0.5, 0.6 estimate para maging solid to vapor lang. And in the choices, ito lang naman ang possible, si letter A. Ayan, kaya yun yung sagot natin. Ayan, so solid, liquid, vapor, and increasing temperature. And next, how many independent thermodynamic variables are required to determine the thermodynamic state of liquid water and steam in equilibrium? So, para siyang example natin kanina kay helium. So, balik tayo kay Gibbs Phase Rule. So, for a water and steam, meron siyang one component lang kasi isa lang naman yan. And meron siyang two phases. Basically, H2O lang siya na in two phases. So, substituting that, ang degree of freedom lang natin ay 1. So, isang variable lang yung need natin malaman para makuha yung state ng liquid and vapor natin sa equilibrium. So, for example, yung given temperature natin na 99.61 degrees Celsius, ma-identify na agad natin na yung pressure doon is 1 bar using our steam table pwede. Ayan. So, homework natin. Why? Bakit ganun yung nangyayari? Why is this so? Ayan. So, that's it for today's videos. If you have any more questions or may hindi clear, you can always email chen.acads sa Gmail namin, or you can message us through our Facebook account, which is Chen Acads Hub. So thank you for listening, and I hope you have a great day.